All right, this video is on section 3.3, where we are going to talk about frequency distributions, but this time for quantitative data. Now, doing a frequency table for quantitative data is a bit more work because there aren't just straightforward categories to just list the categories and then start doing the frequency, relative frequency, and the percent. We have to create what's called classes. So, first example, a data set containing the heart rates of 50 students is given below. However, looking at the individual data is not very revealing. Even with only 50 observations, there are just too many to really get a good idea of what's going on. So before, when we first started chapter 3, we started talking about how if there's 30,000 data points, it's just not possible or feasible for us to look at the raw data and know what's going on. But I wanted to also make it very clear that raw data in any sense, no matter how small or big, it's still very difficult. We look at this table, it's not ordered, it's not organized in any way, and it is the raw collection of heart rates for 50 students. And you really can't just quickly describe what's happening. You can't tell a story, and you can't see the min and the max instantly. There's just a lot of organizing that needs to happen before we can really see what's going on in the data. So instead of trying to examine or analyze 50 data values, a frequency distribution can be provided and it will help summarize what it looks like. So here they created classes, which if you're like, how the heck do they know what to do with the classes? We're going to go through it step by step. Don't you worry. This is just an example of why we would want to create classes. So they created numerical classes. Each class has to be of equal width. That is really, really important for non-misleading comparison and a valid analysis. And now we can see that with this summarized table, that the highest frequency is between the 77 and 86 range for heart rates. Okay, there are some who have very low resting heart rates. I'm assuming these are resting heart rates because those are not high enough to be really exercising. We have a fairly frequent lower resting heart rate. So typically between 67 and 86, that is pretty fair for resting heart rates. This is a little high, but still in a normal range. And this is extremely high for a resting heart rate. That one individual might want to get checked out. It is now easy to see that the overwhelming majority of the heart rates are between 77 and 86 beats per minute. Further, heart rates above 96 and below 67 are uncommon to this population of students, that is. These conclusions could be considerably more difficult to establish without the organization of this frequency table. As you saw in the raw data, that was not at all obvious. How do we come up with those classes? So the steps will be that we have to determine first how many classes we want. Typically, the number of classes we want to stay between is between 5 and 20. Anything less than 5, you're not really looking at much because you're not comparing much data. And anything over 20, you get to be a little overwhelming and you really can't take in what you're looking at anymore. Then, after we determine between 5 and 20, depending on how big our data set is, we'll determine which count of classes we want. We determine the class width by taking the maximum, which is the largest data value in the set, subtract the minimum, which is the smallest data value in the set, and divide by the number of classes we chose to use. We chose to use, and I'm emphasizing that because many students come back to me and say, how do you know how many classes to use? They're trying to look for some sort of calculation or formula, and there is none. It's just a choice. Now we need to find the class limits, lower limit to upper limit, using the class width and the number of classes that we deemed we were going to use. And then we determine the frequency of each class. Again, I'm going to do an example at the end of this PowerPoint, so it's coming up very soon, and walking through these steps step by step so you see it done with an example. The relative frequency we've already practiced in the categorical video, and remember that's the part over the whole, so it's a fraction that we write in the 4 decimal place decimal, where that relative frequency can be easily turned into a percentage by moving the decimal place over 2 places. And the other 2 columns that can be used in a frequency table is a cumulative frequency and a cumulative relative frequency, which essentially is how you would add in your head. And we don't use those very often, but you'll see examples in your homework, but they won't be something that I'm necessarily focusing on. So let's walk through an example. And again, I don't have it in presentation mode so that I can type in while we are recording. Let's create a frequency table for quantitative data. So let's say that I had a class and there are 24 data values here of 24 students, and I collected their height in inches. Now, this is again a survey that I typically do in class. I'll collect data right there on the spot for my 24 students. But let's pretend that these are heights given to me from 24 students in a classroom. The first thing you want to do is take this raw data, which is very difficult for me to determine who the shortest and tallest person is. Are we have more short or more tall, or are they more in the middle? So the first thing you want to do is order the data set. Now I can see that 58 is the shortest student in the room and 77 inches tall is the tallest student in the room. I can also see that my mode looks to be 66 inches. That is the most frequently repeated data value. And the only reason why I can quickly read some of those statistics off of this organized, ordered data set is because it's such a small data table. If this was 30,000 data values, I could still easily pick out the minimum and the maximum when I order the data set, but finding a mode might be a little bit more difficult. Now, after you've ordered the data set, you want to determine how many classes. Since we are working with a smaller data set, only 24 data values, I'm going to choose the smallest number of classes so that there's enough frequency in each of the classes and it's not just 111. So I'm choosing 5. Now I'm going to calculate the class width. So my tallest person, 77 inches, minus my shortest person, 58 inches, divided by the chosen number of classes, 5, and it comes out to 3.8. The rule of thumb is to always round up. And I mean, if this came out to 3.2, you're still going to round up to a class of 4. Now, the reason why we round up is because if we don't, we run the risk of getting to the last class and the upper limit actually cuts off the maximum value. It would stop at like 76. And since we only want 5 classes, we don't want to create a 6th, and we don't want our classes to be unequal width. So we don't want to just put an extra data value into the last class to include the maximum. That is also incorrect. So when we round up, we don't have that issue. Now, the only issue that does arise, so there's pros and cons about rounding up, but the only issue you will potentially run into is sometimes the last class is empty. There will be a frequency of 0. So we do run that risk if the decimal is really low, but I would prefer to have a class of 0 than to be an unequal width by trying to fit in the maximum or having more classes than I wanted. So now that we have the class width, which is 4, we now need to build the lower and upper limit of each class. You start with the minimum. So I've already put 58 in here because I knew I was starting with the minimum. And every class has exactly 4 numbers. So you can't add 4 to 58 because that would be 58 plus 4 more. That's a width of 5. So it's actually easier to add 4 to get your next lower limit than it is to worry about going to the upper limit. You could add 3. So it's up to you. Really, there's no right way to do this. So you could either add 3 to the lower limit or you can add 4 to get your next lower limit. So if I add 4 to 58, I get 62. That'll be the beginning of the next class. Add 4 to 62 and I get 66, and 70, and 74. So those are my 5 lower limits. Now to get my upper limits, this upper limit needs to end right before this lower limit. There should be no gaps and no overlaps. So that means that this upper limit should end at 61 because the next one starts at 62. Okay, I could either continue that pattern. If this is 66, this one should end at 65, or I can do what I did to get all the lower limits, which is adding 4 all the way down. So 65 plus 4, 69 plus 4, and 73 plus 4. Ooh, good. I again want to make sure that each one of these classes has exactly 4 numbers in it, no more, no less. So 58, 59, 60, 61. Good. 62, 63, 64, 65, and so on. I also want to make sure that the last class does include the maximum, and it does. So now my class is 58 to 61. So we make it a little bit more neater and put it together. 62 to 65, 66 to 69, 70 to 73, and 74 to 77. Those are my classes. We're going to need those for the next table. So once we have built our 5 classes of equal width using our class width we calculated in the prior step, we are ready to build the full frequency table. So let me paste my classes in here from the last slide. And now we have to count the frequency of each of these classes. So that's going to require me to go back to the data. So I'm looking in this first class, I am counting every data value that is between 58 and 61. So we're going to come back to our ordered data set. And I see here's 58 to 61. Okay, so there are 1, 2, 3, 4, 5, 6. A count of 6 data values that fall into that class. So in my chart, I am going to put 6. Now I need to look for data values between 62 and 65. Okay, 1, 2, 3. There are 3 data values between 62 and 65. So I am going to enter 3. There was a count of 3. Now I'm going to count how many are between 66 and 69. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's an 8th one up here. I'm going to come back down here and put that there are 8 data values that fall within 66 to 69. Now let's do 70 to 73. 1, 2, 3, 4, 5. There are 5 data values that are between 70 and 73. And lastly, we have 2 in the last class that are between 74 and 77. Okay, so what I did miss in this table is a total column, so that would be helpful. So let me insert a row below. Put this back up. Okay, so this is my total, and let's make this all bold. So we are editing on the fly here. And now I want to add all of these up. So we have 8 and 2 is 10, 15, 21, 24. That's right, I did say I have 24 total. So what's good is that by counting it again and not just assuming there's 24, that helps with making sure that we didn't miss any, that when we were counting the data, that we didn't leave one out or we didn't count one twice by accident. So verifying the total is a good idea. Now, relative frequency, remember, that is taking the part and dividing it by the whole and then coming up with the decimal. So literally in our calculators, I am taking my wonderful calculator, and you take 6 and you divide by 24 and it comes out to 0.25. I like putting a 0 in front of the decimal because then I don't use it. If you don't have a 0 between the before the decimal, sometimes it's very difficult to see the decimal. It just looks like 25. Oh, sorry. There was a fly that just flew into my face. That was unexpected. So now we have 3 out of 24, and 3 out of 24 is the decimal 0.125. Okay, I typically like 4 decimal places, so I'm going to keep consistent with my message of doing 4 decimal places. It just makes it look so neat when you do it that way. 8 out of 24 comes out to be a decimal of 0.333333. Might need an equal here. Here we go. Ooh, I meant to put the 0 there. That's where that came from. 5 out of 24 is a decimal of 0 equals 0.2083. 2 out of 24 which is 2 out of 24, which is 0.0833. And your total, just like in the categorical table, should be a 1, plus or minus a very small decimal place if you rounded more up than down. And let's move our decimal places over. We have 25% of the class is in the heights of 58 to 61. So a quarter of the class is quite short. And this is my imaginary class because this is not a real data set. 12.5% of the fictional class is between 62 and 65 inches tall. 33.33% of the class, so a third of the class, is between 66 and 69. Oh, so that's a higher percentage. So they are taller than they are shorter. 20.83% of the class is between 70 and 73 inches tall. That's pretty tall. If you look, over 50% of the class is 66 to 73 inches tall. And 8.33% of the class is 74 to 77 inches tall, and this should add up to 100%. That is how we would construct from scratch a frequency table for quantitative data. So that concludes 3.3.